I'm going to start with the idea that there's a function that can be represented as the series k equals 1 to infinity of x to the k over k. And the question involves finding the intervals of convergence of both f prime of x and the integral of f of x dx. Now f prime of x is going to be equal to k, I'll take that back, the sum of the series from k equals 1 to infinity of k, because I'm just looking at my rule and using the power rule, so I drop that k, times x to the k minus 1 all over k. And that rule is going to simplify into the sum of the series from k equals 1 to infinity of x to the k minus 1 power. Right, notice we just used the power rule on the rule for the series, nothing more. And this series, just so you can have a sense of it, when k is 1, the first term would be 1. When k is 2, the second term would be x. When k is 3, the next term would be x squared, so on and so forth. And you should recognize this as a geometric series, right, where the first term is 1 and the common ratio is x. And geometric series always converge when the common ratio is less than 1. And more importantly, we should, the absolute value of the common ratio is less than 1, which means that the interval of convergence for this is from -1 to +1. And notice how that contrasts with the original function, which would have an interval of convergence of -1 to 1, including -1. So two keys here. One, to find the derivative of a function represented as a series, you just take the derivative of the rule. We'll have to test the intervals of convergence. And the interval of convergence of a derivative can be different from a function, and it can be different in the sense that you can lose an endpoint. Now, if we were to consider the second part, what is the integral of the series k equals 1 to infinity of x to the k over k dx? We're just going to integrate the rule, which means the integral of this x, the power needs to be increased to k plus 1. The denominator will include k times k plus 1. And since we integrated with no limits of integration, this will be plus some constant, c. And the issue is, we know this is going to converge from -1 to 1, but what's going on at the endpoints? At x equals -1, the series is -1 to the k plus 1 over k times k plus 1. and the series converges by the alternating series test. When x equals 1, the series goes from 1 to infinity and will just be 1 over k, and distribute this in, k squared plus k. This will converge by the comparison test. I'll compare this to 1 over k squared. That always converges, so will this. Which means that our interval of convergence in this case is from -1 to 1 inclusive, including the endpoints. So a couple things to take from this. One, the ability to take the derivative or integral of a function that's represented as a series is really just taking the derivative or the integral of the rule for the series, and you still need to test endpoints to find out about the interval of convergence.